So without further ado, we are going to kick off. And tonight's lesson, we're really just going to pretty much just go over everything we've learned so far about probability in the last 5 lessons. So we're going to kick off with a question on Venn diagrams. Fairly easy one, just to get us into the groove and to get us thinking again about Venn diagrams. So have a read of the question, and I'm going to give you about a minute to work it out there on your own. And so don't post answers yet. Let's just give everyone a chance to think. And then in about a minute or two, I will call for answers and we'll see what you've done. Okay, so I'm going to be quiet for now and let you think. And I'll check back in about 2 minutes. By the way, we are just doing question A for now. You don't have to do question B yet, just question A. Right, okay, so if you're ready with your answers, pop it in the chat. What are the prime numbers between 1 and 20, and then the factors of 30? Pop it in the chat. The Chandra is off, kicked us off with the first answer. Keith is saying his answer with an at the end. Okay, and we've got the prime numbers between 1 and 20. Let's go, everybody. We are about almost 100 strong in the class, so I really want to see like a total answer bomb in the chat with everyone's answers coming in. Even if your answer's already there, pop it in the chat. Let's all get going. Oh, I like how, who's that who did the brackets and everything? Anam put all the brackets and everything around it. Okay, so that looks good, everybody. So the prime numbers between 1 and 20 will be 2, 3, 5, 7, 11, 13, 17, and 19. And we close the brackets. Okay, so if you are using set notation, that's what it must look like, okay? And that's what the question asked for. It asked for a curly bracket with all the prime numbers between 1 and 20. So pay attention to the detail and make sure that you do that with the curly brackets. And some of you included 1. I think 1 is in the list. Did I see? No. Okay, so no one thought that 1 was a prime number. Okay, well done. All right, so let's do the factors of 30. Pop those in the chat. Let's see. Watobians know their factors and stuff. Make sure you've got them all, guys. Make sure that they are all there, all the factors of 30. Definitely 1. And if you remember from grade 8 how you did it, 1 and 30 are factors. And then 2 and 15. I don't know, that's how I learned to do it in grade 8, and it still sticks with me to this day. 3, and 3 times what is 10, and then 4 doesn't work, 5 works, 5 goes with 6, and there's my list. Done. Okay. Now we are going to draw a Venn diagram showing the individual elements in each set. But do you notice that some are in both sets? So we've got the 2, the 3, 2 and 3 and 5. Those are in both of the sets. So those are going to be in the intersection. Remember that word, intersection? We learned that word during this course on probability. You'll make sure you have all of them and make your corrections. So we're going to say set A is the 2, the 3, the 5, the 7, 11, 13, 17, 19. So fill that in. And then those that overlap, we put where the 2 circles intersect. So that's 2, 3, 5. Let's start with our intersection first, and then we put the rest. So for event A, which is a prime number, we write 2, 3, 5. We've already done. So it's 7, 11, 13, 17, and 19. And then the ones that's in B, we've got 2, 3, 5 already. We need 1, 6, 10, 15 and 30. Okay, so now we've basically put everything into our Venn diagram and we are done. Give me a thumbs up if you're happy with that and if you understand all of that. And if you are not sure, ask a question. Right, let's see some thumbs up. If there's anything you're wondering about at this stage, you must just ask a question. Okay, wonderful. Lots of thumbs up. Okay, one more in our warm-up round of Venn diagrams. Excellent. I see lots of thumbs up. Well done, everybody. Feeling much better about these Venn diagrams than what we did 2 weeks ago, I think. Okay, so let's look at question 2. We've got these numbers here in a set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we've got A, which are the multiples of 2, and B, the multiples of 3. I want you to now complete the Venn diagram for the individual elements in each set. Remember the sample space, all the numbers that we are looking at are in the curly brackets. And then the multiples of 2 are going to go in event A. The multiples of B are going to go in event B. And then it looks like they are overlap. And I think that's pretty obvious because we know that some multiples of 2 are also multiples of 3. But remember, this is your sample space. These numbers, 1 to 12. You can't include other numbers. You can only stick to the sample space. For those of you who have been around since the start, we use that example of me trying to get dressed in the morning using clothes from Miss Coco's cupboard and not my own cupboard. That is not my sample space. That is her sample space. So we can only take from the sample space. Okay, do that quick and then we'll check in, see how you did. Also remember, some things are not going to go in event A and event B. Not everything's going to fit in the circles, and then we just leave them outside the circles. Okay, right. Let's see how you did. You can just check your work at home. So where's our 1 going to go? Our 1 doesn't fit into A or B. It's not a multiple of 2 or a multiple of B, so it's just going to hang out outside the circle. Still part of the sample space, though. Then 2 is a multiple of 2. 3 is a multiple of B. And so we've done that one, that one, that one. And then 4. 4 is a multiple of 2. And 5 doesn't fit into either A or B, so we just leave it outside. 6 is a multiple of 2 and a multiple of 3, so we put it in the intersection. And then 7 doesn't fit into either, so we leave it outside. 8 is a multiple of 2. 10 is a multiple of 2. 11 doesn't fit in anywhere, so it stays outside. And then 12 is a multiple of 3 and of 2. So in your intersection, you should have 6 and 12, and then 2, 4, 8, 10 in A and 3 in B. Let's see some thumbs up.
You may have skipped 9.
Oh, did I skip 9?
Yeah.
Sorry about that. Quick.
There we go.
9. So 9 is a multiple of 3. It goes with B. 6 is in the intersection. Okay, right. Booker also took her hand down. All right, guys, let's see some thumbs up in the chat if you're happy with that. Okay, warm-up round complete. Let's get on to one of the more serious worded questions with these Venn diagrams. Okay, well done. Great. I see lots of thumbs up. Lots of thumbs up. Okay, great. Okay, I am going to give you some time to read the question. And why is 1 not a multiple of 2 and 3? Remember, 1, when you are doing multiples, you're counting in that number. 2, 4, 6, 8, 10, etc. And the same with 3. And 1 does not, you can't be counting in 3s or in 2s with 1. Right, so everyone else, just when you are done reading, post your reading face or any other emoji with glasses so that we know that you are done reading. Sure, Michael and Leah, I think these guys have been in the class for a while. Haven't we done this one before? No, we haven't. Quite sure we haven't. Lita and Tando. Okay, so everyone is done reading. Okay, so I'm going to see, since you guys have now been in the class for a little while and we've done quite a few of these and you've done your quiz on these, let's see if you can do this one on your own. Just remember, you always start with the intersection, the things that are the same. If you do not have an intersection, an actual number for intersection, then you need to make that equal to x. Okay, so I'm going to give you another minute or two to start your Venn diagram. Let's see how this goes. We'll check in about 2 minutes, but you must start drawing. Just focus on your Venn diagram. Don't look at the questions yet. We don't need to right now. We just need to figure out our Venn diagram first. If you have solved for X already, you are welcome to put it in the chat. Let's see if anyone has solved for X yet, the intersection. Yes, Andiswa.
Ma'am, I would like to ask about how did you find out that there's an intersection? Because 20 people do not like chocolates, 36 like only whites only, and 50 like brown chocolates. So I'm not sure how you found the intersection.
Do you notice that the numbers add up to more people that were in the survey? So there were 80 people, but if you look at the numbers of people, it's 20 and 36 and 50. That's more than 80. And that is the clue that that there is an intersection. And then you always start from that point. If you don't know how many people liked brown chocolate and white chocolate, then you need to make that equal to X. I see lots of answers getting in the chat. That's really cool, guys. Well done. Lots of answers. We're going to see now if you're right. I just want to give it 30 more seconds. If you do have your X and you are confident, you can start looking at the different questions. Nelo's X is 6. Okay, let's have a look. I've done it here already just to make things go a bit quicker. So we put the 20 outside of the 2 circles because that's the people who do not like chocolate. Then we put the X in the overlap between the brown chocolate and the white chocolate. And then we subtract from the number of people who like the brown chocolate, we subtract the overlap. Otherwise, we are double counting. And that gives us the number of people who only like the brown. And then the white chocolate, we do the same, 36 minus 10. Then we make this equation where we add everything together. The 20, we do not like chocolate, 50 minus X, X, and the 36 minus X, that gives me 80. And we solved that equation, X is 26. I'm so proud that so many of you got that. Well done. Excellent. Well done, everybody. Okay, so now that you've got your X as 26, you must just figure out what your other numbers are. So the people who only like brown chocolate, that's 24. And then the ones who only like white chocolate, that's 10. Because now we have to answer the questions. So what is the probability of somebody liking white chocolate and brown chocolate? So they like both kinds of chocolate. What do you say? Pop it in the chat. Probability. Remember, probability has to be a fraction, and you always put it over the total number of elements in the sample space. And in this case, it is 80. And well done, we are simplifying as well. So guys, at this stage, I expect you to know to simplify your fractions and to calculate probability, putting it over the total. Those things must be very clear in your mind at this stage. Okay, so 26 over 80 is right, but we need simplified fractions. We need 13 over 40. That is the right answer. Okay, quite a few of you posting that. Well done. Let's see everyone else for the next one. The probability of liking white only. So only white chocolate. Okay, so be careful here. Read the question very careful. White only. Pop it in the chat. Ntako, you're on the money. That's right, 1 over 8. If we are looking at white only, and guys, if you don't just put an answer down and you don't know why it is right, okay? So if we are doing white only, we are looking at this part of the Venn diagram. This is white chocolate only. And the number of people who like white chocolate only is 10 out of 80. And that simplifies to 1/8. Okay, let's see who's been listening this whole time while the lessons have been happening. What is the probability of liking white or brown chocolate? Remember when we do or? Sako says 3/4. Let's see anyone else. This time I'm not going to say anything about who's right and who's not. I want to see what people are saying. Put your answers in the chat. And while you do that, I'm going to give Tukolo a chance to ask his question. Tukolo?
Hello, ma'am.
Hi there.
How are you?
I'm fine, thanks. How are you?
Ma'am, I can't understand how we got the 1/8.
The 1/8, so 10 people like white chocolate only, and there's 80
Yes,
people
ma'am.
in the sample, so it's 10/80, simplifies to 1/8.
Oh, okay. Thank you, ma'am.
Okay. Okay, we're again getting some different answers in the chat. Come everybody. Or means it's brown or white. So it's not just those who like both, it's those who like white and brown and both. So it includes everything. Okay. And for that, we're going to do 24. Those are the people who like brown chocolate. Plus 26, those who like both. Plus the 10, those who like white chocolate. And that simplifies to 3/4. Okay, so by the time you leave here today, you must understand and if it's the probability of A and B, like we had in the first question, if it was white chocolate and brown chocolate, and you need to understand or as well. So questions like question 1 and question 3, that must be very clear by the time you are done with these lessons today on probability. Yes, Danao.
Hi, ma'am.
Hi.
I don't understand how we got 3/4.
Did you check what 24 plus 26 plus 10 is?
I don't. Oh, okay. Okay, I see it now.
So it's everyone who likes brown chocolate, those who like both,
Plus,
and
oh,
those who
okay.
like white chocolate. So that adds up to
Put it
60.
over 80.
Yes.
Oh,
Simplify
okay.
the fraction, 3/4. Okay.
Okay, thank you, ma'am.
Okay, no problem. Lucanio's got his hand up. And Lucanio, before you ask your question, I'm just going to give everyone the next question to do. Okay, so here we're not going to draw the Venn diagram is drawn for us. So I now want you to do the questions, hold answers, don't post answers yet. We will do answers as soon as I call for them. Okay, but I want to give everyone a chance to give this a shot first. There's a few of you who are very quiet, and we're going to start calling on people. Come. Remember what we said, one of our house rules is to participate. So let's participate, guys. This is how you learn maths. Okay, Lucanio, your turn. Ask your question.
Hello, ma'am.
Hi there.
On the question that says and or the one okay. So ma'am, when they say and, it's when they ask people who eat both or people who are on the two events.
Yes.
And then or you have to add all the events and the people who eat both or
Yes.
people who are on the both.
Yes, that's
events.
right. But not all the events. So if we go back just briefly, notice we didn't include the 20 people who don't like chocolate. But when we did the calculation, we took everyone who liked brown chocolate, everyone who liked white chocolate, and everyone who liked both, because that covers or. brown or white. It's you either like the one or the other, or you like both. But that's what or means. Okay.
Thank you so much, ma'am.
Okay. Right. Back to our question. Ms. Kaka, could you just help Warren, please? Still a little bit lost. Okay, let's hear your answers. What is the probability of a learner picking Sprite? Pop it in the chat. Who's that? Bukamuso. Well done. I don't know if everyone's just copying answers or if you actually thought about this. Well done, Nicolita. Yes, that's right. People who like Sprite is everyone in the Sprite circle. The Sprite circle is this one here. Everyone who's in the Sprite circle are those people who like only Sprite and those who like both Sprite and Coke. Okay, so the probability of picking someone who likes Sprite is 19 plus 4, that's 23 over 30. So you had to count those ones who like both as well. Yes, Anati. Anati, ask your question.
Madam, I was asking about they say it's 19 over 30. I was want to know how, but you already explained it, which we will add 19 and 4 and then become 23.
Yes, that's right, Anati. Well done. Okay, now what is the probability of a learner picking Sprite and Coke? Pop that in the chat. And you like both Sprite and Coke. So where are we looking for that? We're looking here in the intersection. That is where and sits. Sprite and Coke is 4 over 30, which we are going to simplify as a fraction because you have to simplify your fractions for probability. That's 2 over 15. Okay. Right. It's 2 over 15, guys. It's the people in the middle that I've highlighted in blue. What is the probability of a learner picking Coke? Now, think carefully before you do this one. Yes, okay, that's better. We are looking at everyone who likes Coke. That includes the people who like Coke and Sprite. So we're going to do 10 out of 30, which simplifies to 1 over 3. Good. Now, what is the probability of a learner picking Sprite or Coke? Now, before you answer, think back to the previous question, what we did with the chocolate, the brown chocolate or the white chocolate. Think back to that before you answer, and then put your answer in the chat. What is the probability of a learner picking Sprite or Coke? Yes, Bukamuso.
Hi, ma'am.
Hello. Can't hear you, Bukamuso. Okay, guys. I agree. It's 29 over 30. Okay, yeah.
So, ma'am, I know that this person is not here, but then I wanted to ask because I was writing my test on probability this morning. So I wanted to ask, there was a question whereby they asked me, what is the is a complexity in English, the complexity of the data. For example, now,
Yeah.
okay, so we have now
sorry, the rest of the class haven't done that question and can't see the question, so it would be a little bit unfair to do that. Miss Coco is going to help you with that one, okay? All
okay,
right.
no problem. Thank you.
Last question is, determine if the event is mutually exclusive or inclusive. If you think back on our previous lesson, the one we had on Tuesday about mutual exclusivity, is this event mutually exclusive or inclusive? Pop your answer in the chat if you know. I want to see some more answers. Right, there we go. Yes, it is inclusive because
Somebody
we have
just said
overlap.
mutually.
Sorry?
Sakila just says mutually. I think there's something missing there, Sakila. The answer can't just be mutually, then it needs to be either inclusive or exclusive.
But it's not mutually exclusive anyway, because there is overlap. And if you remember from Tuesday's lesson, and please go watch it again if you're still not sure about mutually exclusive, because we went into that in quite a lot of detail on Tuesday. And we said there cannot be overlap if two things are mutually exclusive. We've got Sprite and Coke. If it was mutually exclusive, then you only like Sprite or you only like Coke. But here we have 4 people who like both. So this is an inclusive event. Okay, right. I'm going to put the last question up while I take Bom's question. Everyone else can start on this one so long. Last one, give it your best shot. Think about everything we've learned. And yeah, let's see if we can get full marks for this answer. Yes, ask your question.
Ma'am, I
Yes.
don't understand how we got 29 over 30, ma'am.
We take the 19 plus the 4 and the 6. 19 plus 4 plus 6, because it's OR.
Oh. Okay, thank you, ma'am.
Okay. Right, put a thumbs up in the chat if you are done. You still have a bit of time, but if you are done, and I mean with the questions as well, not just the Venn diagram, with everything, then put a thumbs up in the chat. Keith's got the brain. So if Keith is the brain, who's Pinky? It's because you haven't spoken the whole day, Emilio. You need to maybe just say something. No, it's not lasagna. It's spaghetti and meatballs. That is what Miss Coco's having. Mommy's showing a confused face, or I don't know, an over it face. Right, let's have a look, everybody, because we also have to do quiz. Right, so 5 people do not speak any of the 2 languages, so we put them outside the circle. Just going to move things around a little bit. Okay, the intersection, we don't know what the intersection is, so we make that X. So this was exactly the same as the chocolate one. We go 75 minus X, 43 minus X, and then all of that must add up to 110 because there's 110 people in the sample. It can't be more than that. So your X must be 13. Now, who got 13? Put a thumbs up in the chat if you got your 13. Actually, don't just put a thumbs up. Let's put a party face in the chat if you got it. Party face if you got 13. Yay, there's 1, 2, Vokile, well done. An iPhone, we need to change your name. Riachile, Leah. Emilio, is that your party face? Umpile, Gabriel, yay, good stuff. Nsako, nice. Okay, guys, you don't just put a party face, you got to get the answer right too, eh? Oh, there's tears, Lashandra, I'm sorry. Oh, someone got 13 and a half. Yes, Emilio, there can't be 13 and a half people speaking both languages. Okay, so you have to check that. Okay, and Andre's posting the cowboy. Okay, well done, everyone. Well done if you got that. And then let's do our probabilities now. So you have to be able to, you can only do your probabilities if your Venn diagram was correct. So if you didn't get X is equal to 13, then the other things are gonna maybe differ. Ms. Coco, can I ask you to just see to Bukamuso? Bukamuso, we're in a bit of a rush to finish the lesson. So Ms. Coco is going to answer your question. And then what is the probability of a learner studying only Afrikaans? Come guys, let's get this one right. Only Afrikaans. Put it in the chat. Only Afrikaans is 31 over 55. Nice. 31 over 55. We are only looking at the ones that only speak Afrikaans. Now, what is the probability of a learner studying English and Afrikaans, Afrikaans and English? So, and where we're looking, the intersection. Well done, Gabriel. 13 over 110. Does that simplify? I don't think so. No, that is as far as it'll go. 13 over 110. And then what is the probability?
Can I just ask a quick favor, ma'am? Can I ask you to scroll up just a little bit so we can see the question? Yeah, just like that. Is that okay?
Yep. Okay.
Thank you.
And what is the probability of a learner not studying English? Not doing English means you are doing Afrikaans or you're doing nothing. I'll help you with this one. That's the 62 plus 5 over 110. Oh, well done, Fence. Yes, 67 over 110. Oh, there's a few of you got that. Kamba as well. 67 over 110. And then are these events mutually exclusive or are they inclusive? Let's see, what are they? Are they mutually exclusive or inclusive? They're inclusive because some people speak both. They are definitely not mutually exclusive. Right, guys. Well done. You did it. You finished probability. You made it through these Venn diagrams. You got your and your or straight. So I'm going to hand it over to Miss Coco so that she can give you your final quiz to do. Well done, everybody. And I see you Tuesday for financial maths. Bye.
All right, guys, I'm going to pop the link to the quiz in the chat.
You're on mute, Miss Coco.
My word, I'm having a whole conversation by myself. Guys, the link to the chat is in the link to the chat. The link to the quiz is in the chat. I'm doing so wonderful. I'm hungry. I want my lasagna. Now I'm calling it lasagna. Oh my goodness, I'm a mess. Okay, I'm going to pop the link to the quiz one more time in the chat. You guys go ahead and do the quiz. If you're still not feeling confident about the concept, remember, you don't have to do the quiz right now. You can always rewatch the videos and then do the quiz when you feel more comfortable with everything that was covered today and over the past few months.
But do it before the end of the weekend so that we can put your name on the leaderboard if you do well.
Yes. Okay. So yeah, make sure that you do it before then because we're going to get the results early next week. All right. That's it from us. Let me pop the link one more time. I see Anam has a question, ma'am. He says, ma'am, please explain what exclusive and inclusive means.
Okay. I think you need to go rewatch last week's lesson, Anam. Mutually exclusive means that there's no intersection. The two things cannot happen at the same time. You cannot be at school and at work at the same time. You can't be in both places at once. But I think if you're still stuck on that, you need to just go rewatch past Tuesday's lesson on mutually exclusive events. Okay, Anati, you've got 30 seconds to ask your question, then we've got to go.
Madam, please can I ask how did you get 67?
The 67 are those people who are not studying English. So we don't look at anything that's in the English circle. So this is the English circle. So we only count the 62 who only speak Afrikaans and the 5 who do not speak Afrikaans or English. So 62 plus 5 is 67 over 110.